So we stopped at something called as electric field lines, right? Field or flux lines. They both have the same structure. When we sketch this field using these field lines, we get to know its structure. Okay, we'll be able to tell whether it is uniform or not, right? How it is behaving and all. Are used to sketch the fields the field line is the path along which, this is what we stated, right? A small positive test charge moves when it is kept in the field. Now, let us now sketch the fields, the charges. Number one, a positive point charge plus Q. Positive point charge. I want to sketch the field line. I will keep a small positive test charge near it. It experiences the repulsive force along the line joining and moves along the line continuously away from the positive charge Q. Goes till infinity. If I keep it here, it travels in this direction, creating this field line. If I keep it here, it moves along this line. On the plane, they will have something called as circular symmetry. Please look at it. Ask if you have any doubt here. These are the field lines. Uniformly distributed in all the directions. If it is an isolated positive charge Q, these field lines continuously go away from the positive charge till infinity. And at each and every different point at which I can keep the positive test charge, a separate field line is produced. On the plane, it is supposed to have circular symmetry. It is having. In the space, it will have spherical symmetry in which the lines are going out radially in all the possible directions. Listen. These field lines appear to be coming out from the positive charge. Because of which, look at it. Since these lines appear to be coming out from positive charge, is said to be the source of electric field lines. Check it. A statement which is extremely important for us to talk about divergence. Number 2. This is actually isolated positive charge. First case. Next, number 2. Isolated negative charge. Minus Q. We know if I keep a small positive test charge near the negative charge, it will not move at all, because that test charge will experience the attractive force, because of which it goes onto the surface. Because of which, to draw the line, I have to keep it somewhere away from it. Whatever may be the point at which I keep, that experiences the force continuously towards the negative charge and travels it, gets terminated on the negative charge. In the same way, if I keep it here, it comes like this. It always, because I am trying to sketch the field lines using generate the standard field lines. Whenever I want to generate the standard field lines, I have to sketch it by using an isolated positive test charge. All the lines will go towards and get terminated on the negative charge, because of which negative charge is said to be the sink of electric field lines. You're comfortable? Since the electric field lines appear to get terminated on the negative charge, negative charge is said to be the sink of electric field lines. Please check it. Maybe very small points, but still, for us in the course of discussion, highly useful statements. These are all. Now listen. The field lines of isolated positive and negative charges have or basically are radial producing spherically symmetric field in the space, in three-dimensional space. Okay. I think one Mr. Faraday conducted an experiment having seen the results of that particular experiment. He introduced a term called as displacement flux and flux density. The flux lines that he was talking about are same as this field lines. I'll tell you when the time comes also. He gave a set of statements. The structure of the field lines is independent of the medium in which the experiment is conducted. You agree that? Because of the medium, the magnitude of the force experienced by the charge can change, but not the direction of it. Given that the field line is the path along which an isolated, very small positive test charge moves, it always gives me the direction of the force. It will not talk about a particular field line, cannot speak about the strength of the field. Please concentrate, because I want to tell all the points that are required for us to get into mathematical derivations. He gave a statement that we will be proving later on also, that every charged object, if it is a positive charge of q coulombs, emits q coulombs of flux. He started talking about the number of lines created by a particular charge. Q coulombs of flux lines are generated by any positive charge of q coulombs, and q coulombs of flux gets terminated on any negative charge of q coulombs. He gave the statement. Whenever, wherever, irrespective of the medium, you have plus q coulombs of charge on an object, it for sure creates q coulombs of flux, independent of the medium in which it is placed. In the same way, if minus q coulombs of charge is there on an object, q coulombs of flux lines will come and get terminated on that negative charge. Very, very importantly, irrespective of the medium in which the charge is placed. Like you know that I have a light source of fixed power. Wherever you keep it, in whichever the medium that you keep that light source, the amount of light or the luminous flux emitted by the light source, the amount of luminous flux emitted by the light source is determined by the amount of power that it is consuming. We know that. I spoke about it in the beginning itself. Now I am using it. The amount of luminous flux, imaginary only, we cannot see it. The amount of luminous flux emitted by any light source is fixed, and it is determined by the power rating of that light source. But the intensity of illumination of a point which is at a distance d from the light source depends upon the medium in which that point is there. Flux is independent of the medium. Intensity depends upon the medium. Flux is independent of the medium. Intensity is dependent on the medium. Similar to the fact that fixed number of flux lines are emitted by a light source of fixed power, if there is q coulombs of charge, it emits q coulombs of flux. Check it. Taking that, spherically symmetric field. Please see this. According to Faraday, fact it is. He gave the statement. It's like no assumptions in the gas laws. No gaseous theory. When you start, we start with a set of assumptions. He's talking about these assumptions to be proved to be correct. Any positively charged object of charge q emits q coulombs of flux. Charge of q coulombs emits q coulombs, the flux and charge of same units. Independent of the medium in which the charge is placed. Number one. Number two. Please see. When the flux comes out of the object, from a point, it comes in the direction perpendicular to the surface at that point. In the sense At the surface, it is normal flux. Statements to be proved to be correct, I will show you during the derivations itself. These are basically the points that to be considered for the case of Gauss law. Let us look at them parallelly, because anyway we are seeing this. That's why it is normal flux. Next. Independent of the medium. Listen. At any point, if we draw a surface perpendicular to the flux lines, at any point, if we draw a surface perpendicular to the flux lines, the flux density, the flux per unit area of that surface please remember the statements, because these are given directly, later on proved mathematically. The flux per unit area on the surface is called as the flux density. It is needed to say that it is a normal flux density, right? Because at any point in the space, you will understand everything of itself, don't worry. You are drawing a surface which is perpendicular to the flux lines, it is like wavefront. And at a point, you are talking about the flux density. How to talk about it? If psi is the notation for flux, consider area delta A tending to 0 at that point on the surface. See the number of flux lines delta phi passing through it in the direction perpendicular to it. In the direction perpendicular to it, delta phi by delta A is the flux density which is perpendicular to that particular imaginary surface. Normal flux density. It's a vector d bar. I'll prove everything. At any point in the field, right? In the medium with permittivity epsilon, if the flux density is d bar, the electric field intensity E bar is equal to d bar divided by epsilon. Flux density independent of the medium. Field intensity depends upon the medium in which we are conducting the experiment. We are talking about the field. Please check. These are the points given by Faraday. The direction, whenever we say that E bar is equal to D bar by epsilon, where epsilon is a scalar quantity, direction of D bar and D bar are same. At a particular point, because of a charge Q, D bar is independent of the medium, but E bar depends upon the medium. If D bar is the flux density at a point, normal flux density, electric field intensity at that point is E bar equal to D bar by epsilon. In every case, I want to show that instead of following the numerical formula procedure, if you follow this procedure, the electric field intensity can be determined easily, provided there is a structure, there is a symmetry for that particular field. In the field where there is no symmetry, we cannot use this. This only will really explain divergence, Gauss divergence theorem and all purely, perfectly, and exactly. So I gave those statements here. Next. Listen carefully. A point charge of Q coulombs. Because it is a point charge in space, it is a sphere of zero radius. Its surface is a spherical surface. If there is a charge of Q coulombs on this spherical surface, Q coulombs of flux is generated by it and sent in all the directions equally in the space. Please follow. This we know. This is the field line structure. Same is the flux structure. Now, I want to determine the flux density at a point which is at a distance d from the point charge. Let us say I want to determine the flux density d at this point. Which is at a distance d from the point charge. What does it have to do? I have to draw a surface which is perpendicular to the field lines everywhere. If I draw the surface which is perpendicular to the field lines, it should definitely be a spherical surface. Now, close the sphere because it is uniformly distributed. Whether it is delta phi by delta A or phi by A doesn't matter because it is everywhere same. Q coulombs of flux psi is equal to Q. If I take a sphere of radius r, d bar is equal to what? Psi by 4 pi r squared AR, radial. Flux by total area. Area of the spherical surface is 4 pi r squared, which is equal to Q by 4 pi r squared AR. What is electric field intensity? Since d bar is Q by 4 pi r squared AR, E bar is equal to d bar by epsilon is equal to Q by 4 pi epsilon r squared AR. Perfect. This is what Coulomb's law was giving us as the electric field intensity. If psi is equal to minus Q, flux density d bar is what? Minus ER. Minus ER because it will be inwards. What is E bar equal to now? minus q by 4 pi epsilon r squared dr. Now, if you say that electric field intensity is basically determined assuming the charge to be positive plus q, if it is negative, that substitute that value as negative value so that the electric field intensity gets automatically reversed and gives the proper direction. Check it. At each and every stage, I want to prove this wherever there is symmetry. I want you to really remember these points.